Okay, let's talk about a single pane of glass. The idea that you have one view into all of your infrastructure and your performance data and your services and things like that. So it's something that is a hard problem to solve. I don't know that I've seen it solved very well. I know the way I like things, and I know that when I usually work for someone or another company and I go in there and I see what their monitoring solutions are, I immediately recognize a lot of patterns that are not, I wouldn't associate with actual single pane of glass. So this is something I have a lot of opinions on and I think about a lot, and it's one of the problems I'm sort of trying to solve with chart density. And so what I've been doing yesterday, I spent the entire day. I went to make, a small change to the K2 metric capabilities, which is part of K2, which is available out there. And these code changes will probably be pushed in the next, today or tomorrow maybe. So I went to make some small changes because there were some problems. It had kind of collegedly got together to do what I wanted it to do, but I had never sat down and refactored it. So I decided to refactor something small, and it turned into an entire day of refactoring. I'm very happy with the results. I'm very happy where things are. Organizationally, it's a lot easier to understand, and things are named better and all that, but obviously there's been a lot of changes. I'm going to walk through some of that, but I'm going to show you, the what I'm aiming at and where I'm going. And just keep in mind everything you have here is available if you want to use it. This is currently like the back end for chart density. It's this is what's going to be the initial back end. So I won't go through all the changes here. Let's go look at SQL Developer. And I've got this big query. This is going to be a view. It's going to be available as a default view. It's probably going to be called metric work underscore V. And it's going to be kind of the main view on metric work. And the main reason we need this is the one dynamic thing, one of the big changes was prior to today or prior to yesterday, if you wanted to track a metric, you needed to let me know, do I want to track the rate? Do I want to track the delta? Do I want to track the raw value? And then we would run that calculation on the incoming data and store it. And then if you wanted to change it, well, if you wanted to go from, say, a rate to delta, we've got all this history that's stored as a rate. So now what we do is we track all three, and the rate is per second, and then you can set up what you want to view, basically. So this is kind of what's going on there. It's saying, hey, if your calc type is, say, rate per minute, what we're going to do is we're going to divide that rate per second by 60, and that's going to be your calc val, and that's kind of what you're interested in. So you can change that anytime you want. You're not changing any of the history or any of the underlying data. I'll say that with one caveat. If you look here, there's these histograms. Like this one is for percentiles, and there's another one, one for percentiles and one for percentages. And those I have to know, like, okay, you seem to be interested in the rate, so when I compare what percentile the current rate is, I got to compare it to something. I've got to compare it to the historical value of the rate. So those will get stored, and your scores on those will be related to what you're saying you're interested in. So it shouldn't change much, but you could change it. It's just that the score, your rolling percentile scores, and your rolling and your average, and I'll show you those in a minute, those would kind of be related to something else in the past. We're not going to go back and try to figure out what that was and all that kind of stuff, but those really aren't that important. If you're making the change for that kind of thing, you're probably just change going forward. As far as the query goes, you can always view what you want. It's just if you change that value of the calc type in the stat work table or metric work table, well, that's going to happen. Okay. So what this is going to be a view. You see, and other than that, it's pretty much pulling raw columns, and we're pulling from metric work. Now, how the K2 metrics, or what I'll call stats, works. I don't like the word stat. I like the word Statzilla, which is a domain I got. But stats, are really statistics, and these are really metrics. It's a little something different. Statistics are something that you build off of metrics, but these are metrics. So you use K2 to insert data into stat in. That is kind of the inbound table, and then from there it takes care of it. You got to create a data set. You have to have minimal information when you insert data into stat in. That can be done through your own RESTful interface or what have you. I do have it working for Chartzilla. And then the behind the scenes processing processes those records in that inbox, in that queue, and they get written out to stat detail. So if you just want like traditional time series data, I want a row, and each row represents a metric, a data point, and a value, you look in stat detail. That's getting written out all the time. So that's how 99% of stuff works. But in order to get to stat detail, that data goes into something called stat work. And stat work, that row is aggregated. So right now I've got it set up so that rows are aggregated hourly. So if I'm collecting data every 5 minutes for the Oracle metrics. And so you're going to have what? Or maybe 6 minutes, I don't know. But you're going to have like 10 to 12 values that make up that row. And at the end of the hour, that gets rolled out into the metric work archive table. So now you have a history of that hour. And that reduces the amount of data that you need. So instead of having, if I'm collecting 2,000 data points every 5 minutes, so instead of having, say times 10, 20,000 rows for that time period, I'm aggregating that into 2,000 rows. And then there's other things you can do to eliminate the amount of data that you're storing. You can basically say, throw away the boring stuff after 7 days. Keep the interesting stuff. And that's going to be fairly easy to do with a single pane of glass type of design. And I'm going to argue that that begins with this metric work table, that this metric work table is my single pane of glass. I try to envision is in the future that I could have billions of rows here, and I could quickly, through a simple query or a set of queries that may then be visually displayed, I will know what's going on and all of the anomalous behavior in my environment. Now maybe all this is irrelevant since AI is here, but I don't think so. I think AI is probably going to over-inform and miss things at first. Although it's impressive what it's doing. But if anything, AI will be, I think, easier to implement with this style of table in setting up training models and things like that than it will be maybe traditional data, and it'll be less expensive because it's already aggregated in ways that you can use it. So let's look at, let me just go through this. There are some things here that aren't here yet, but we're going to be adding. So we have our metric name. Of course, these are related to a specific instance, a specific host, that kind of thing. So there is the question of should we add host name? Stock data doesn't need a host name. So if you put host name in here, it becomes kind of, well, this is not for stock data, this is for performance. So that's a kind of an internal argument I'm having in my head. We can go over here to the end. I put this at the end because this is what the actual key is that's passed in, and it's giving me an instance ID, a statistic, a class ID, and the type Oracle. And in general, I should probably add host because this is just for test data, but in general, you want that key to be 100% unique. You want to know where it's coming from. Now, one of the problems you have with things like, Kubernetes and Docker environments and containers and services like that is those services are getting spun up, and the host is not so important. It's the type of service that you need to track. And so you do need to be aware that your data to compare to is going to be gathered based on what it has in this row. And so that's something that I'll need to design in. I don't think it's that hard. Basically, you can pass in the uniqueness but you'll also pass in but this is how I want you to, these are the attributes that you need in order to figure out what historical averages to use. So I might throw data at you with thousands of host names, but I will tell you that when you go to look up the average, when you store aggregated values for this data, store it, without that host name, so that it lands in the bucket of, my application dev environments, something like that. So that remains to be a problem. That's a problem to be solved, but I could not solve that problem until I did the work I did yesterday, because that's a lot clearer to me now than it was before yesterday. Okay, so we have more data than just the name, but for sake of this view, I'm putting the data right here because this is what I'm going to care about when I write a query. The idea is if it's single pane of glass, I should be able to write a query that shows me at least then what I want to see visualized. I shouldn't start with the visualization. I should start with the query and be able to get down to those visualizations quickly. And I would say that this grid control is fabulous. I don't know if anything exists in the web that is quite this. Well, I guess it does, but they're written in, whatever that thing that the Git client is written in, Atom, or I forgot. But we really need great grid controls. For Oracle Apex, interactive report is pretty good, and interactive grid's okay and all that, but it's not quite as performant as this. And you need it is cool that you can filter on columns and all that, but I would say a great grid is what I'll be looking for. And of course, this, what do you do on mobile for that? That's where mobile falls flat. And but we need a lot of this information. So we go through and we've got our metric name. This is telling us the row count. So it's telling me how many values are currently in this row that make up the aggregates, the average and stuff like that, So how many times have we collected data? And I said, this is one row per hour, but you could do one row per day. You could do, there's a set things that you can do. But I think it'd be fairly, I think you can maybe do any time pattern that you want. I'd have to look at that, but it's certainly capable. So if you want to do every 4 hours, there's ways of doing that. And actually, this is just, I'm going to write a to-do. Oh yeah, app to-do. I'm going to go over here though and do it. So what I can do is to-do, use external trigger to roll data in metric work. So yeah, a lot of times I'll think of things while I'm talking. So what that would be is like, maybe you just have an external trigger that says, every 4 hours you roll the data and do it that way. So that's something that would be a cool feature. And that way you don't have to design necessarily a date format kind of template that does it. Anyway, so we have our row count, and then we have our calc value and our calc eval description. So this is I'll show you for CPU. Maybe I should show CPU. Where metric name like CPU. So, I really don't like seeing my CPU in hundredths of a second. So what we do is we have a calc eval field which says divide by 100, and that converts this to seconds. So this is my seconds, and I'm also interested in calc per minute. And so my calc per minute is 0.01. The average value is 0.01. That's the average value for these 3 records that are currently making up this row. This is the received value. This is the average of those received values. So there would be 3 records making up this value right now. And this is the received value as a percentage of the average received value reference, of the average reference. So right now it's running 105%. This number is is a counter, so it goes up. I'm not really interested in the received value for this one. I'm interested in the rate as it shows there. So then we have our received value average as a percent of the average reference. So this is showing me the last number that was shown compared to average, and this is showing me the average, the three values compared to average. It gets a little confusing, but once you understand it, it makes sense. So and we're not interested in received value, so let's go to our rate per second. So here's our rate per second. We're seeing 38 hundredths per second. Our rate per second average is 35 hundredths of a second per second. So if I'm getting that right, we're running about 20-30% CPU of a CPU right now. Our rate per second average, as a percent of we're 120% of the reference. This is 120%. And then our rolling rate per second average as a percent of average. So this is like a rolling thing. It'll keep, I could keep as many values in there I want. I'm keeping 24, so it's basically 24 hours of that percentage is right here in front of me. And maybe we'll see later, but it's very easy for me just to look right here and see, if something's been out of whack for a long time. I don't need a chart. I can see it. It's a percentage. It's a value. I've got 24 of those values. The oldest one is on the left and the right. And I'll show you the code for that, actually. You might be interested in using this. It is in this big giant trigger here. Going to be when we roll the data. So here's where we roll the data. We do an insert. If we've got rows, we insert into the metric work archive table. And this is where we do our rolling values. And so what we're using is the arc-SQL shift list. We're L trimming, making sure we L trim that first comma. And basically the list is going to be the field that you want to store the list in, so it kind of grabs that. The token is what separates the values, that's the comma. Max items 24, and then we just add to that. So we shift it, so it takes the one value, rolls it out if it's more than 24 values in there, and then we append the latest score. And so you can see I'm doing that. It's a very useful tool that's in K2, part of arc-SQL. And, I can create spark lines or things like that off this data fairly easily also, or some simple charts that are in line, maybe right in my grid. I haven't tried that, but, right in our interactive report, put some charts right in there, small charts and things, using Google Charts potentially, because I do have a Google Charts API to work with. Okay. So let's see these rolling things. And they're giving me historical context without having to go write another query. I can go write a query and look at this data. And the UI, I can drill down, but it's helping me see the data right here. So you got this. So you're comparing like the last value to your average, and then you got a rolling average for that one record for that one row, which may be 3, 4 records, 5 records, 6 records. What is the average value, basically hour to date for the current hour, and what is the comparing of that? And then we have our percentiles. So, it's looking at the stat detail data occasionally and pulling out like, well, what is the range of this data? What does it look like on a standard distribution, and where is it landing? So each update, if we have 3 records, for example, this one, they landed in the 10x, which is low, and the score kind of shows you where they're landing. So it's like a 1 to 100, or 0 to 100. If it's 0, they're all landing down here. If it's 100, they're all landing up here. Now percentiles, some values have very tight ranges, and landing in the 90th percentile all the time really isn't necessarily something to freak out about. Or it's definitely not something to freak out about. It really matters on the data. You want to look at other things. Some of the query tools I've seen, it's like they focus on 90th percentile. That will get you down to some stuff, but I don't know that that's always the most interesting thing. So here's our rolling percentile score. So I can immediately look at this, and I'm looking for like what's in the 80s and 90s, and what's been in the 80s or 90s. You can see how easy this is to look at. This is very, very powerful. And then here's our averages. So these are the comparison to average. And because this metric, we're interested in the rate, these things are landing comparing to the rate, to the previous rates. And this has only been running for a day or two yesterday, because I rebuilt it yesterday. So it's only got 24 hours of data to go on. As you get more and more data, it can get more and more specific. So we can start to say, you've got enough data now that we can just look at the same day or hour of day. I can't remember if it's day of week. I think it is. It's hour of day and day of week, and we'll compare to that historically now, as opposed to everything. And in fact, one thing I might add is on this row is like, how does this compare to all the averages? How does it compare? Even though I have enough data to compare this to the same hour of day and same day of week or same day of week, how does it compare to all data? So where are you landing in those buckets? And what you'll be able to come up with is I will be able to look at any value here and be able to kind of auto-categorize them as, and the way I want to do this is like smart tags. So there's going to be some tags that you can use when you're querying. You can say, show me everything that's hot. So hot would be, would be stuff landing up here. Cold would be over here, and cool would be here, warm would be here, and normal would be here. So that with those tags, you can categorize, like show me cold, because cold could be a problem too. If your CPU goes cold when it should be warm, maybe you have a batch job that's no longer running or something like that. Something might have failed. So you want to know that too. And then there is the there becomes the time that it is hot. So something that is hot for a long time is hotter. So that becomes kind of like how the scores can work. You can have scoring that that score builds over time. Or if something is cold, you have a cold. It's cold, but how cold is it? Is like how long has it been cold and stuff. So those are things that'll be throwing in there. So here's our rolling percent score, and then we get into just a lot of the things that you're going to need if you're building an interface, like obviously the metric ID. And the metric ID is formed by, I believe it's just base 64ing the data set and this metric key together to get a unique value. So we don't rely on you. You're supposed to provide us unique value, but we don't turn this into the key with your data set. We need a unique key, and we generate one. So let's just go back, get rid of our metric name CPU, and we are looking at rate per sec average as percent of average of 0 descending. So it should show us some of the top results, we'll say. Another thing we can do is we can add ranking here. And then that can go into show me everything that's, across all these values that's in the top 90th percentile ranked across all these different averages and stuff, the scores. So we can have our ranking mechanism. And then we could build kind of open sourcey ranking mechanisms and scoring mechanisms that you add on your own and you can use. So you can basically write your own scoring mechanisms if you think those are better. Another thing that I'm going to be adding is what we'll call noise gates or noise cancellation, right? Like I could probably care less if my CPUs are within certain bounds, then I just don't even care. I don't want to see that. And so you couldn't be hot if you're not within a certain bound. We would just say that, right? And so there'll be some thresholds you can set. So this is where the UI becomes important to be able to click in a spot and very quickly cut and paste, filter, update all these rows. You should be able to create your basic alerting. You shouldn't have to write alerts. You shouldn't have to write a lot of alerts. You should be able to, within this row, describe the characteristics, the expected behavior is such that the alerts become automatic. So some set of very generic alerts maybe, but you could set hard threshold alerts if you want in this, but basically you're kind of, you're able to quickly sort, group, this kind of thing, and set all these things up without having to click around through a lot of pages, a lot of interfaces. So that's something that we're going to try to do here. So this is like what's probably our top stuff right now. None of it's going to be too exciting because I'm not really pushing this system. But if I just want to roll across and see, I don't have a lot of the rolling data because some of these fields were just added. But let's look at our rolling. Actually, let's look at rolling percents. So I'm just going to look down here quickly, and you can see nothing's standing out. We can even come down to the last 2 hours pretty quickly, and we're just trying to find some 80s and 90s. There's not. Let's see if I can scroll down and see anything that really. This is what we call boring data. That one's interesting because it's dead 50s across, and it stands out. It's very visual. It's very easy to see. I'm not gonna. I bet that's a PGA, UGA. Yep, UGA memory max. I did some things there, and I think that's why that's doing that. And there could be a bug in there. Yeah, there's nothing too exciting here. So anyway, this is what I call single pane of glass, or at least this is what I call the starting point for single pane of glass. We're going to add some filtering, some more meta, ability to add meta. We're going to, this is where I'm going to use ChatGPT, my ChatGPT API. I am going to go through every single one of these automatically in a program on the back end and get ChatGPT to document what those things are. And then I'm going to include it here. And that's what we would call a profile. So, hey, apply the Oracle SysStat profile to this data set. And it will look at the data set and say, well, yeah, I see you've got these things, and it'll document them and add documentation. So that immediately shows up in your UI. So you could do that, and you could, maybe eventually add your own notes and things like that. We're looking way down the road as far as what chart density is going to be doing, hopefully. But, okay. Well, I think I've gone long enough, almost 30 minutes here. But yeah, I just wanted to show this off a little bit. Still got some work to do, and then we'll get back to doing Stripey, more billing, transaction-y stuff with Stripe on chart density. And I'm going to have to go fix all the stuff I broke in chart density when I rewrote all this stuff. So. Thanks for watching. This code will be available in the dev branch of K2, built on apex.com/K2 in a couple days, maybe sooner, but probably a couple days. I'll probably want to get back into chart density and fix everything, and because that might make me have to fix something here or something like that. So, okay, thanks for watching.